So, I've been working on a theory that is derived around spherical matrices, but see, I don't write anything out. It's all just in my brain, and I think about it periodically, and I call that working on it. But to me, I don't see an eagerness on it. I don't understand a genuine just here on my screen. There's no urgency, and so I'm trying to recalculate all the things that I just thought about, and I'm turning it into a video. Where did that come from again? Anyway, so the fifth dimension. What the fuck is that? You have the first dimension, which is either a point or its existence. Let's just look at it in two separate ways. The second dimension, which is force, or it's a line. And so you have an infinite set of the initial point, and then you get to the third dimension, which I say dimensions have after they have HALVE, they have after the second. So everything starts to have after that. So we don't actually have HAVE. We don't have a fourth dimension. We don't have a fifth. What we have are you can create these lines, but third dimension technically would be acceleration, that creates a curve, right? So you have 2 points of acceleration, which is still a halving. It's half of a dimension that otherwise would create more parallel shapes. And so when you start to structure this in the same concept, is that you have your acceleration, and you're like adding another acceleration on another plane. It's still the same fundamental forces, and they create curves instead of the fundamental, like the standardized structure, where they're like, oh, okay, line, and then you're like, okay, let's just take another line and create a three-dimensional object. And that's two separate ways of looking at dimensions. So the fourth then is considered time, which is then invariably understanding how long this has been accelerating and when you're adding the same similar force and how it creates those things. That would be three-dimensional. And so you have these lines that then come here, and they create an angle, and so on and so forth. That is the third dimension. It's time. Like, we literally live in the fourth dimension by the standardized model. Is that they call the fourth dimension time, but truth is that we actually live in the third dimension, which is time. And so when you get into the fourth dimension, which is curvature, we don't have anything other than, like, standardized matrices that are relativistic matrices that Einstein created for us. I was trying to figure out spherical matrices based on that other structure of time, looking at it like that, and that everything pushes and nothing can ever pull. So the logic is that when you reduce it down to a matrical, is that a word? Matrical, I'm gonna use that word. So matrical existence in physics is that, like, the curvature of these dimensions of time and forces create some of my favorite scenes of this movie, so I'm going to be distracted. But that if you were to create a matrix that is spherical rather than relativistically, you know, three-dimensional. Now I'm distracted. Anyway, you could unify these and create a fifth dimension. That's the only way I understand what they're talking about in the article about what is the fifth dimension. The fifth dimension is so close to us and all this other stuff. Anyway, I don't buy into that. I'm more like, well, if we understand multiple perspectives of theories, that you're going to encounter different interpretations of dimensions, which are, I suppose, relativistic to the viewer, right? Observer relative, which would be really interesting if there were articles, but I don't want to read the articles. I don't know if Albert, because we're on a first name basis, me and Albert. Do you think Albert and I talk about this? Anyway. Okay, so when you get into spherical matrices and you have relativistic matrices, which are like that. Spherical matrices function on separate dimensional variables and calculations, while relativistic matrices function on basically everything we've been doing up to now. So when you get into the spherical ones and you look at atoms, which are spheres, that you're taking straight lines and trying to curve them instead of taking curved lines and slightly less curving them, if that makes any sense. You're not making them straight because nothing's straight. I mean, everything is imparted upon gravitational fields. That's how I see it. You're not like looking at the sun and you're like, oh, everything was perfectly straight until it just countered gravity. I think that's kind of where Einstein went wrong. And I just love to have a conversation with him. If he could live this long and know like everything, you know what I mean? And then I'm like, hello, can I talk to you about like things? I want to just like talk and think about things. It'd be a great conversation, but you can only have it once, sadly. So I suppose it's better he's dead. And it's better that I die. Who wants to live forever anyway?